Let's take a look at this example 5.7. It says find the tension in each cord if the weight of the suspended object is W. So it wants me to find the tensions in terms of W for tension A, B, and C. So the easiest one to do is C to start with. So C is pulling up on our object, but at the same time gravity is pulling down. Because our object is not accelerating, I can say that the sum of the forces in the y direction is going to be 0. And so I have tension C minus mg equals 0. Now you might ask, why did you add up the forces and then clearly subtract them? Because these are vectors and I need to include their directions. So it's a positive tension C and a negative mg, so it's plus a negative mg. That means tension C is equal to mg, which in our case is the weight of the object. So I know tension C is weight. So typically what we will do in a scenario like this is when we draw this free body diagram, I'll typically ignore this string and I'll just make it part of this mass. And so there'll just be my free body diagram that looks more like this, that I'll have these two, and then I have the weight pulling down. I have tension B pulling this way, tension A pulling that way. All right, so let's go ahead and use this one to solve for A and B. Now, looking at those angles, they tell me these angles are 30 degrees on the left, 45 degrees on the right. So this was 30 degrees. This was 45 degrees, of course, drawn to scale here on the board. I like to have my angles next to where my force starts. So I'm going to put this as 45 degrees and this as 30 degrees. In order to generate our equations, we want to generate one in the x and one in the y. When we have things at angles like this, that means we need to resolve those forces into components. So I'm going to go ahead and resolve TB into its two components. So this one is going to be TB cosine of 45 because it's adjacent to the angle. This one is going to be TB sine of 45 because it's opposite the angle. Same kind of deal over here. We have tension A cosine of 30, tension A sine of 30. One thing that I'll see that works for people is we'll redraw this and we'll only draw the components. So I'll have TB cosine of 45 pointing that way, TA sine of 45 pointing this way. Same kind of thing over here. Oops, TB, that was close. TB sine of 45. Over here, TA sine 30 and TA cosine 30. And then lastly, W for the weight, or mg if we were doing it that way. So what's nice here is I can see which ones are in my x direction, and I can see which ones are in my y direction. It makes generating my x and my y equations a little easier at the start if you're having trouble like looking at this because it looks a little busier. So let's go ahead and create those two equations. So the sum of the forces in the x direction is 0 because it is not accelerating left or right, so that's going to be a 0. Make sure when you're doing that in your head, it's not that it's not moving, it's that it's not accelerating, because forces tell us about a change in motion, okay? So looking in my x direction, I have TB cosine of 45 minus TA sine of 30 equals 0. So I've created my first equation. My second equation here, I'm going to sum up the forces in the y direction and set it equal to 0. So I do the ups minus the downs, or these are both positive forces. This is a negative force based on its direction. So I have TA sine 30 plus TB sine 45 minus W equals 0. At this point, I've generated my equation. So what we're going to do next is we're going to solve this system of equations. So we're solving for TA and TB, and we want them in terms of W. So the first thing we're going to do is we're going to go over here and we're going to solve this for TA. So I'm going to move my TA over to the other side and divide my sine 30 back. So I'm going to have TA is equal to TB cosine of 45 divided by the sine of 30. Cosine of 30. Let's try that. Now that I have what TA is equal to, I can go ahead and substitute that in over here. So I have TB cosine of 45 divided by the cosine of 30. So I've just substituted in for TA there, so I still have that sine of 30 sitting there, sine 30, plus TB sine 45 equals W. I'm solving for TB, so I'm going to go ahead and factor out TB. Also, I see when I make this factor, I see I have a sine of 30 over a cosine of 30, so I'm going to turn that into a tangent of 30. So I have cosine 45, tangent of 30 plus sine of 45 equals W, meaning TB is going to equal W divided by the cosine of 45, tangent of 30 plus the sine of 45. Now, it's at this point, which would be a good thing for you to try, is try and do it the other way. So here I solved for TA first, substituted and found TB. Go ahead, take a moment, and solve this first equation for TB, substitute it in, and solve for TA. So go ahead, pause it here, and then come back and you can check your answer. Welcome back, of course. So I'm going to end up doing this just a little bit different. So I have TA here is equal to W divided by, so I'm still going to have that sine 30 plus, I'm going to have my cosine of 30 times my tangent of 45 in that denominator. So it'll look kind of similar, but a little bit different. All right, so there is our TA and our TB. Now that you've got a little practice under your belt, go ahead and try part B and then come back to this video. All right, so you gave it a try. I put it up here on the board to kind of walk through just to make sure you did it okay. So I like to keep my angles at the inside, so I changed that 60 over here to the 30 over here. Got my sines and cosines, but if you kept your angle over here, that is fine. This would just be cosine of 60 and sine of 60. That will work just fine, don't worry. Redrew my picture, so I noticed that that sine of 30 here is pointing down that vertical component. So when I come over to create my equations, I got to have a negative sign there, which changes my answers to have that negative sign in there. So go ahead, double check your answers, see how you did.